So, next speaker is Calle Moberg from Cisco. And he's going to talk about addressing some Snijder's do's and don'ts with Yang and Python.
Okay, so my name is Calle Moberg, and some of you in the room will appreciate the fact that I now work for Cisco. With my background, I started out at TeliaSonera working on everything except Cisco. But here I am. So I was invited to talk. I spent most of my days actually in network management, so more manageability in the actual data plane or the forwarding plane or even the configuration plane. So when I started thinking about what to talk about, I browsed through previous years' presentations, and I found one that I found particularly enlightening by someone called Snijder. Is he here? No. Okay, otherwise I would have said thank you, because I stole a couple of parts of that presentation and based my presentation off of. So what I'm going to do is that I've handpicked 4 of the do's and don'ts, and that I'm going to show how we have seen customers tool themselves around it. So I'm going to use things like Python and shell scripts. And for those of you who have heard of me, also understand that I'm going to drag Yang into every conversation, kicking and screaming, because that's what I spent most of my recent professional career on. And so as a little bit of a background, I used to work for a small Swedish company called TailF that was acquired by Cisco. And just for you to understand how narrow TailF used to be, we used to sell manageability frameworks to router and switch vendors. So we would sell the software that you actually log into when you log into eNode Bs from Alcatel-Lucent, some of Brocade's switches, some of Cisco's routers. So all I cared about for many years was the actual manageability framework that's running on the actual network elements, right? So we have really focused on ignoring the data plane, the routing, the switching, and we have really focused on how do you manage these things at scale. Okay, so this is liberally stolen from Snijder's presentation, and he liberally stole it from someone else at Google+. And I think it was a very good one. So obviously these are 2 competitive mindsets going. Here's the geek, here's the non-geek. They start off on the same tangent. The geek finally gets annoyed and says, I'm going to actually script my way through this repetitive task. So he spends some time. The non-geek really thinks he's in the lead here. But at some point, the script actually works and runs, and time is then flat for the actual geek. And in a short amount of time, he actually beats the non-geek by scripting his way through to success. Now, of course, in my mind, just scripting is not really very useful, or it was cool in the 90s. But what we want to do is, of course, to add what could be called Delta library or Delta tools, which will significantly improve the speed with which the geek reaches an earlier win. So by compressing the time he or she needs to spend on writing the scripts, we can, of course, win over the non-geek faster. So again, I'm going to try and go up the stack here and start with something really basic, and then go up to something that I hopefully will have you guys leaning in. Here's a big caveat, though. Please learn from others. There's a huge potential sucking sound of you trying to reinvent things that already exist, and then you end up trying to fix these things that you reinvented, and then eventually you're going to hand it over to someone that is trying to fix your reinvention of a fix, and so forth. So as a general advice, I mean, going in this direction is awesome, but don't reinvent things unless you have to. So I'm going to be super brief on this one, otherwise I'll be here for hours. So what we're talking about when I say Yang, it's a data modeling language for networking. I think it's the bee's knees. I think it changes the game entirely, and hopefully by some of the technical stuff that I'm going to show you, you will agree with me. And what it fundamentally does, per the little red box here, is that it provides people that interact with network equipment a full formal contract language with which you can induce what the box can do for you. And actually it's precise and detailed enough compared to, for example, SMI for SNMP, that you can actually program with it. We spent considerable amounts of time designing this language. It looks something like to the right. It's optimized for reading. We got all the good stuff in there. We got nice versioning rules, modularity, formal constraints, extensibility. I won't take you through that today. RFC 6020 and recently also RFC 79 something something, which is a bumped version of Yang, is good read. A lot of people are using it. We started out as an IETF project. Now it's completely exploded. Most of the standards organizations and also some of the industry consortia, OpenConfig, Open Daylight, and many of the kind of forward-looking groups are now liberally applying this to a wide variety of networking. We have seen crazy uptake in the IETF. I'm part of what's called the Yang Doctors, so it's our task to manage the green line in the middle, the amount of Yang modules that are actually valid and useful. We're struggling a little bit because there are so many people pouring in, which also leads to the fact that we have a little bit of a herding problem. So this is the relationship graph between some of the core things that we have in the middle, which is about interfaces and IP addressing and stuff like that, and some of the other stuff that's happening around it. But we're on our way, and the core here is stabilizing, so hopefully we can start addressing what's on the edges here. All right, so I'm going to keep my pace up here so I don't miss my deadline. There's a couple of tools that I'm going to use, and obviously everything I'm showing almost is available at GitHub. We're going to use a tool called Piang, which is a Python-based parser, validator, and a nice output plug-in framework. It will make more sense when I show it. We're going to use confd, which is actually an old product of TailF that we now give away for free because we want people to not have excuses to implement netconf and Yang. There are some examples that I have in my netconf and Yang training GitHub. And as the kind of hopefully non-crashing end finale thing, I'm going to use a pretty cool interactive Python interpreter web application. Again, it will make sense when I show you. And I'm going to use some of the standard or draft standard Yang modules that we are shepherding through the IETF. Obviously, the first ones that we had to approach was about basic interface management, IP addresses, v4 and v6, some of the common data types, and we obviously had to have the IANA interface types as well. So we'll be a little interface-centric here. The first one, and I particularly love the fact that Snijder called out please love Unix, because then I said, that's great. I can now show shell commands to an audience. That's great. We can break into the shell. His point, my interpretation of his point is that actually don't over-rotate on huge integrated systems. Actually try to think of this as common tooling. Now, the Unix philosophy is obviously small, focused tools that you can string together to perform whatever it is that you want. So what I'm going to do here, in short order, is that I'm going to use a little tool called netconf console that can interact with netconf servers. I'm going to use the Piang parser validator and output plugin, and I'm going to use some XML lint magic and kind of show you how you can build a little pipeline to do useful stuff using these tools. Can you see this, Liman? Is this right-sized? Can you guys in the back see my shell? Now you can see it. Okay, I'm going to do two more. Okay, so I'm in my little shell here. I have a netconf server running on my laptop. So I run the confd server, so it emulates a router. I didn't want to bring a big blinky thing into the meeting room, and obviously there are many implementations of this, but I'm going to use let's call it a virtual version here. So I'm going to use the netconf console tool to query my local netconf server, and this is a very good thing in and of itself. When I open up I need to start it first. Done. What happens when you open a netconf session is that the server will tell you what it can do for you. It tells you what kind of protocol version, what kind of protocol features, and which Yang modules it actually implements. And we're going to focus on the interfaces stuff here. So I'm just going to grep on that. And we see that this server supports IETF, the IETF interfaces Yang module. So now we know, and here's another very, very cool thing is that using a reasonably capable netconf server, you can actually ask the device, in this case the router, for the YANG module. So no more offline SNMP MIB libraries, right? You can actually ask the box for what it's actually running. So in this case, the identifier is IETF interfaces. So we'll grab that. And that's going to come back both as a YANG file, but it's actually hidden in some XML. So I'm going to look in my cheat file because I need to do some actual XML linting to remove the surrounding XML. So now I have the YANG. I've now asked the router, give me the YANG for your interfaces configuration. Okay, but you know, that's just pouring through YANG like this, even though it's, readable, it's not so fun. So we'll hook in YANG towards the end here, and it has an output module called F3, which actually gives you a nice ASCII-based tree view. So suddenly you can actually see the structure and the data types of the YANG module that you asked the router for. And actually you can go a little bit more overboard. We have something called JS3, which actually gives you an HTML version of this. So now you have, a web view of what it looks like. And what we're going to do here is that we're going to turn up an interface. So you can see here that there's an interface list keyed by name, and it's a leaf called enabled. That's a Boolean. That you can figure out, again, by querying for the YANG and looking at it. And there are other ways of actually extracting. I mean, there's a lot of output modules. So you can do things like, for big teams, we've seen many customers actually use UML as the output. So it would look something like this. We would call it IETF interfaces UML. And then we would use plant UML to look at it. And that actually produces, in a little directory here, an image for it. So if you're of the type that really like UML, you can actually project it in this way. Now the point being that you can then query your router for an exact definition of what it can do, and you can transform it into whatever format you and your team kind of like, and you can then navigate and understand how do I interact with this device based on that YANG output. That was fast. Anyone did not follow? Any big question mark? Oh, no you don't. No, never mind you. All right, we'll power on. Number 2, Snijder, avoid shortcuts, right? He's very stringent here. Check for all failure possibilities. I love that, as if we knew about all failure possibilities. But it's a very refreshing that he would say so. Only allow precise coherence to expected results, else recover and exit. Good point. We'll take a look at what we have here. I mentioned that we're going to look at enabling the interface. Okay, so we know that under IETF interface, there's an enabled leaf. So let's see how we can do that. And by some magic trickery, I now invite you to my Python. So here is a lot of text. I would like for you to just focus on this part. That is actually the XML version of that path with 2 values. First, enable is true, and we also need to tell the box that I expect this to be an Ethernet interface. So this XML you could figure out, in this case, by looking at that YANG. And then we use a neat little client library called NC-client to run this. So just by doing that, and of course everything happens in the background, right? We have now enabled the interface. But I wanted to show you actually a second step here, where it gets more interesting. He mentions failure cases, and this is kind of the same setup, it's just that there's more XML. What we're doing here is that we're setting up a static LSP. We happen to know of all this nice XML because we know how to translate from YANG to XML. And the actual code for netconf based on that YANG down here actually makes use of a very neat feature that many vendors, not all, implements today, which is what's called a candidate data store. People with vast experience from Juniper remember this from the CLI. It's a way of actually adding things in a scratch pad, if you like, and then through a transaction you commit this. So you allow the box to actually validate the input before putting it into production. And we make, for people with Python background, we make clever use of context managers, which means that if something happens here, we actually roll everything back. And you could also iterate over boxes if you wanted a full distributed transaction based on the data path expressed in the Yang here. Same thing here, happens in the background, but we can see that we got a nice little RPC reply OK here. So by traversing the Yang, understanding that, and using NC client, we could do a transaction-safe configuration of a static MPLS LSP. All right, we're making our way through Snijder here. Third one, input validation. Now it gets really, really interesting. So he wants us not to only be non-liberal in user inputs, but we need to check everything rigidly, and he talks about business rules. There's a lot of valid configuration, and take it from me, I work for Cisco, there's a lot of syntactically valid configuration that makes absolutely no sense in a box, right? A lot. Actually, the majority of all configuration makes no sense in a box. There's a very thin path through configuration that actually makes sense. And so what we're going to do now is that we're going to introduce some more moving parts. And I want to do this because it can get darn confusing unless I show this. So what I'm going to do now is that I'm going to use an orchestrator. This happens to be my orchestrator. So if you want to know more about orchestrators, I'll be more than happy to talk about it. We're going to use netconf to talk to actually a pretty wide variety of boxes that I have in my little simulated network. My orchestrator actually has a Python language binding on its northbound. So we're going to use a clever contraption called IPython, or interactive Python, to interact with this Python API. And as a web frontend, we're going to use something called Jupyter Notebook. So now you know the moving parts. And I'll just fire up the actual environment here. We make stop here, and we do make start here. So what I'm firing up here is actually a simulated environment with a couple of CE boxes, couple of C boxes based on iOS XR, and there's some Juniper in there also for some multi-vendor flavor. So we're going to wait for this to be done, and we're going to fire up our Jupyter Notebook. And back to Snijder, what we're doing is that in the orchestrator, we will show to the client not the discrete network elements, but an actual service model in Yang. A very simple one that tells the end user, the client on top here, that VPNs have two endpoints that have names and a couple of parameters that has to do with endpoint networks. We need an AS number for it, but that's about it. So when you fire this off into the orchestrator, it will understand if the endpoints are of a particular make or a particular version and translate that. So we're trying to hit the business application level here. Okay, so we're up and running, so now we can start our Jupyter Notebook. So it's a web application, and I have a VPN demo notebook here. Looks like it's working. This is very cool. It's got cells. So what I'm scrolling up and down here are cells. Cells can be of two types. It can be markdown, like this one, which is just free text. And it can be executable content, like this one, that I'm soon going to fire off. And what this first snippet here does is that it connects to the northbound interface of the orchestrator, and it does what we call a devices sync from. It pulls in all the configuration from the devices that it knows about to make sure that we have it so we can work with it locally. So Shift-Enter here, and the little star means that it's working in the background because it takes some time to fetch the configuration from the routers into the local data store. What's cool when that finishes is that down here we can actually have an interactive session. So in our case, we manage the data set that you manipulate in two branches, let's say. One that has to do with the devices that we manage and one that has to do with the services. So in your little Python here, you can actually look at all the different devices that we have loaded into the system. It gives you a nice, actually interactive way that through Python you can manipulate both the configuration of all the devices that you manage and also the service instances. So what we'll do now is we'll move down to the next interesting cell, which is one that actually creates a VPN. So all the activities that I do here is actually done locally to the orchestrator. So we create a VPN, we'll call it corporate VPN. We need an AS number for it according to the Yang module. We need two endpoints, one in Stockholm, one in Gothenburg. And then we need to populate the endpoint. So we happen to know that our Stockholm CE device is CE0 and Gothenburg is CE1, and we know which interfaces, and we know of a couple of nice IP addresses and things like that. So we run that too. And so now we've set it up. According to the business rules, we're ready to deploy this end-to-end VPN actually across Cisco and Juniper through this little Python interface. And again, it's a high-level interface, so all you need to do is apply on a transaction here, and we will validate the input, and we will actually transact that into the network. And there you go. It's done. We now have a VPN from Stockholm to Gothenburg running on my laptop here. All right. If that didn't wake you up, I don't know what. Any questions? Oh, Peter, of course. Yes, Peter.
So the previous speaker talked about he wants to put into BGP what they can already do with SS7 on the data plane.
Did he? Okay, he did. Yeah.
There's a plug. There's a switch. Okay. So the previous speaker talked about putting in BGP, which was yesterday's project protocol, what we can do in SS7 already on the data plane, because SS7, when it sets up 2 switches, it can say continuity check. Why don't we move to the future? Why are people trying to do things with yesterday's protocol still today?
Why oh why? To his defense, he's partially using technologies like this, and to his defense, now I'm channeling him too, is that what you're asking is, I would say, in the real world, in the brownfield organizations, largely not a technical issue. It's more an organizational, cultural issue. And I would venture to say that he would agree in general. Now I'm almost smearing thoughts and opinions here, which is, Peter, you're good at making me do. Yes, he nods acceptingly. Transaction confirmed. Any other questions? That has to do with the content. Mikael, you usually have 1 or 2. See, they even gave you your own mic.
Well, I don't have a question, but I'll make a statement regarding other tools that I'm involved in working on with SysRepo. That is a free open source implementation of the Netconf server that you can use to enable something to be Netconf manageable.
Yes. Good one.
So we're actually now just doing in the process of doing a code drop where there is now both operational and configuration information that you can store in there and RPCs and so on. So if you're interested in, if you have a device that you want to make Netconf Yang manageable, there is free open source Apache version 2 license that you can use. And it's called SysRepo, as in system repository.
I will add this to the slide. You're absolutely right. And it's one of the more promising, I'd say the promising, pure open source implementation of an ambitious server. Yeah.
And it's done together with Cisco and Deutsche Telekom and CESnet, which is the university network in Czech Republic. And yeah, completely open source. And it uses something called libyang, which they have done, that is speaks native Yang and can do all the validation and so on, very useful. So, and it uses Netoppeer, which is a Netconf server, and then it uses SysRepo, which is the data, what do you call it? Data store is the correct term, yes.
Cool.
Okay, thank you.
Okay, so if nothing else, we'll just invoke kill session. Oh, okay, good.
Okay, so also not a question, sorry, but more of a comment. So,
Who are you?
Oh, Christian, also with Michael and Peter, kind of ish on the Deutsche Telekom team. First of all, thank you very much for being here today. I will be doing a talk later today, and I could not have asked for a better introduction to that one, I think, so thank you. But I would like to comment and say that, Netconf and Yang, you showed a lot of things happening, the ITF, lots of models popping up. But on the actual routers that we're using, if you look at Junos, some of you might know that it already has a very good support for this, since it's kind of, I mean, I think they built the precursor kind of to netconf and Yang. So it's in there from day one. Cisco is also, not your part of Cisco, but the other part of Cisco is also doing a fairly good job. So if you are using a recent version of XR, there's very, very good support of configuration as well as operational data. So you don't actually need anything besides netconf and Yang to manage these devices. Also on, I'm not sure how many in here are using Nokia or Huawei, they're like, slightly behind, but there's great things happening there as well. So kind of encouraging, you know, do really take a look at this. It's really useful. Thank you.
Thank you. Oh, floodgates are open. Good.
Hello. I would like to know how Yang, generally speaking, can deal with transactions in states of equipment that take a long time, like days, weeks, customers getting their site provisioned and so on.
Right. So what you normally do for long-lived transactions, and this goes into a whole conversation of, you know, formal ACID transactions, two-phase commits, versus, for example, things like eventual consistency. That takes a little bit more time. So Yang doesn't care so much. It's more towards the protocol, you know, what protocol to use. And arguably, netconf has its strength in synchronous transactions. So what I showed here is good for when you're down to seconds or maybe tenths of seconds. For longer-lived things, many people turn to REST. So there's also a REST interface mapping to Yang-based data stores. But I think the important part, or I would say that the important part is to make sure that the data that you consume is structured in a fashion that it allows itself to be expressed by Yang. Usually helps the most, and then you pick the protocol that is fit for purpose. 4 questions, beat that. Okay, 3 comments and 1 question. All right, thank you very much.